Hello, and thank you for watching this video presented by Kepware Technologies. This video will give a high-level overview of the new product features in KEPServerEX version 5.11, which is now supported on Windows 8 and Windows Server 2012. This release provides important driver enhancements. The ControlLogix Ethernet driver now officially supports Rockwell Automation's version 21 firmware, and our GE Ethernet driver includes new support for bit within symbolic variables, as well as a significant read performance enhancement for PAC systems devices. The release includes the introduction of some new drivers, including the IEC 61850 MMS client driver and the OPC XML DA client driver. Several enhancements have also been made to Kepware's electronic flow measurement offering, including the addition of an EFM simulator driver. These drivers and features will now be discussed in detail. First, let's review the features of the IEC 61850 MMS client driver. Electrical substations facilitate transmission of electrical power and are a critical component of the power grid distribution system. Due to the nature of power distribution, which is typically over long distances, remote automation and control is of absolute necessity. These substations are also found on large chemical and petroleum processing facilities inside large buildings and in power-intensive manufacturing plants. The IEC 61850 protocol is rapidly being adopted for power substation automation throughout the world. Many large substation equipment suppliers such as ABB, Siemens, and Schneider make devices that support IEC 61850. This new driver further extends Kepware support for substation automation, complementing our existing DNP3 driver. The IEC 61850 MMS client is a premium driver available for KEPServerEX. The driver supports automatic tag generation by querying the device or loading the substation configuration SCL file. Communication is facilitated using the Manufacturing Messaging Specification, or MMS, within the IEC 61850 protocol. Data updates may be received by polling a device at a set interval or using report control blocks, RCBs, for unsolicited data. Multiple data updates can be buffered in the server cache and played back to the client to prevent data loss in between scan intervals. Finally, the IEC 61850 MMS client streamlines the setup of the control model for the device. Before diving into receiving data from the device at the client level, let's first discuss setting up tags for the device in the server using automatic tag generation. Automatic tag generation is a feature of KEPServerEX that allows systems to be quickly deployed and easily scaled while minimizing setup time and error. As with many of the drivers in KEPServerEX communications platform, the IEC 61850 MMS client supports the automatic creation of tags using multiple methods. When setting up a new device, in the Device Properties window, users have the option to pull register information from a connected device or the SCL file and populate the server with this data. Going to the Connection tab, we can see that you can load the IP address from the SCL file or enter it manually, and that is all you need to automatically generate tags. Finally, browse to the Database Creation tab and click Auto Create to automatically generate device tags. Now let's move on to getting data from the device using polled and unsolicited methods with the MMS. Users may easily read and write to the device using the IEC 61850 MMS client. In the Device Properties Communication tab, data may be set to be polled at a rate, for example, once every 5 seconds. For optimal communications, users may poll data for an entire logical node at once, where one solicited request would include all the data relevant to the node, for example, the protection node of a circuit breaker. Otherwise, options for polling data at the functional constraint or data object level give users greater flexibility in bandwidth or memory-limited applications. MMS uses reporting services for unsolicited data or data by exception. KEPServerEX then captures this from the device if Enable Report Handling is set to Yes. Data updates will be received from the device to the server triggered on certain events. Triggers for unsolicited data include on data change, data update, quality change, or integrity period. Buffering functionality also exists for reported data and comes with a configurable maximum queue or buffer size, and playback rate, where playback rate is how long a value will be maintained before it is discarded from the queue. The last feature we will cover on the IEC 61850 MMS client driver is the ability to specify a control model for a device. In order to control the function of an object, such as turn a switch on or off, users must write to a group of tags at once. These include OR_CAT, OR_IDENT, control num, test, and check. The IEC 61850 MMS client driver makes this process easier by implementing a control model setting for the device. To set the control model for data attributes in the CO functional constraint, simply enter the required information such as OR_CAT or OR_IDENT in the device properties control tab. When users wish to change a control value, for example turn a switch on or off, they will be able to write to a controllable object's control val tag without having to specify the static information of OR_IDENT or OR_CAT every time. If needed, these values can always be changed by users dynamically as well. The IEC 61850 MMS client driver is available for individual purchase or bundled in our Power Suite, which includes drivers such as the DNP3 driver. Now let's explore another new driver in this release, the OPC XML DA client. The OPC XML DA specification helps fulfill the need for a data access specification across the internet, leveraging XML and SOAP. It has been used in applications where relatively small amounts of data are transferred across the public internet. For example, the wind power industry uses this specification to pull data local to a wind farm and transfer it to operations and management's headquarters. Users can connect to any OPC XML DA server using this new driver. For example, users may now monitor data from the Siemens SiMotion controllers with embedded OPC XML DA. This driver will be included in the OPC Connectivity Suite alongside the OPC UA client and the OPC DA client driver. These client connectivity options allow KEPServerEX to act as a data aggregator, unifying your data into one source from any of these OPC servers on a subscription or pulled basis. As you can see, users simply enter the remote or local endpoint URL for the XML server and import items of interest to populate the KEPServerEX project with this data. Finally, to wrap up this release, let's look at the electronic flow measurement, or EFM, functional enhancements. These enhancements include configurable addressing for our Enron Modbus device driver and an EFM simulator for offline testing. Additional features such as partial upload failure handling and support of the DB1 protocol for ABB devices further enrich our comprehensive EFM offering. The driver for devices that support the Enron Modbus protocol was introduced to KEPServerEX v5.9 release. The original Enron Modbus specification defines set address ranges for each data type, but with our 5.11 driver, this is now completely configurable by users. Start and end addresses for data type ranges may be managed in the Address Ranges tab in the Device Properties window. The native data types a user may specify include Boolean, short, long, and float. When users add or modify an address range, the Edit Address Range dialog box prompts to specify the data format, register range, and Modbus function codes. The export and import options allow address range configuration using the CSV file format. With this enhancement, the Enron Modbus driver can work with devices that do not use the standard Enron address extensions. Finally, the EFM configuration tags may be automatically generated for the Enron Modbus driver without being connected to a live device. Go to the Database Creation tab and click Auto Create. This allows users to validate their configuration mapping. This release also comes with a useful EFM simulator. The EFM simulator is a driver that simulates EFM data produced by flow meters like TotalFlow and Fisher-Rock. This allows users to generate EFM data for testing the file exporting configuration without having to configure a physical EFM device or flow computer connected to the server. Simply create a channel, device, and meter using the EFM simulator and generate data that can be exported by the EFM exporter plugin. To start simulating EFM data, enable meters in the EFM meters tab in the device properties window. Users have the ability to give a unique name to each meter, turn it on and off, and control what kind of data will be generated in the simulated file. In the Simulated Meter Data tab, users can set the EFM simulator to automatically generate new data every few minutes, hours, or days. This data is stored on your local machine. Finally, click Generate Test Data to create simulated device data immediately. Now go to the EFM exporter plugin. Create a poll group and add the EFM simulator meter to be polled. This meter has already been configured with a CSV flogout and PGAS exporter. The meter data can then be exported as real data by issuing an on-demand poll command to the poll group using the quick client. Do this by writing a 1 to pollgroup1.poll. Once the data is exported in the appropriate format, for example CFX, these files may be consumed by the corresponding EFM accounting software. This allows the evaluation of Kepware's EFM solution without hardware connectivity. That concludes the feature tour of the new release of KEPServerEX v5.11. Remember, KEPServerEX now also supports Windows 8 and Windows Server 2012. Thank you for your time and interest. Please contact our sales or support teams for additional information. Visit Kepware.com to download a free, fully functional product demo.